All right, thank you, Elle, and hello, everyone. Thank you for joining me today. Yes, my name is Wilhelm Hocker, and I lead the Enterprise Solutions team here at Parasoft. And today, I'm going to be covering strategies for effective microservices testing. Before we get started, I should disclose that yes, my Parasoft is where my career began in the software industry 13 years ago. And Parasoft has been in the software testing business for over 30 years, where we help our customers implement continuous quality using our platform. I've helped many companies with their agile transformations and modernization efforts, where none of it would be possible without the right testing strategy and test automation in place. And so I'm looking forward to sharing what I've learned throughout my career in hopes that it will help you get a handle on your microservices. So, microservices have been an industry trend for years now, yet I still meet teams that are failing to reap any benefits and they're struggling with failed releases when it all needs to come together and work. And so in this talk, I'm going to be referring to microservices, services, and APIs interchangeably because the testing concepts are going to be very similar, however you describe them. And this talk, it's titled Three Key Steps for Effective Microservices Testing. And to describe them simply, these are record, monitor, and control. And I'll be explaining how these concepts can be applied to your testing strategy to ensure that you have efficient and high quality releases. Now, just because the software we're discussing is a microservice doesn't mean that you have a free pass to skip unit testing, because code is code and unit testing is a fundamental quality practice that helps teams catch regressions quickly, early, and in a manner that's going to be easy for developers to remediate. And the ugly truth is that I commonly meet teams whose unit testing practice could be described as spotty or reactive at best. And this generally boils down to a business decision why it's not a priority for them. And this is really unfortunate because the market for tools has matured where a developer's life is much easier and more productive with unit testing now. And so the trade-off between cost and quality isn't as severe as it used to be. And I'm not going to be deep diving into unit testing today, but this was really an honorable mention that I couldn't in good conscience ignore when discussing software testing of any kind. And since I'm on the topic of software quality practices owned by developers, the industry has also matured with dedicated coding standards for API development. In 2019, the international nonprofit OWASP released the OWASP Top 10 API Security Standard. And so coding standards like this one help microservices teams avoid the common security and reliability issues that could introduce business risk to their projects. And so, trying to adopt a coding standard without tools, it's going to be like trying to spell check or grammar check a book from Dostoevsky page by page visually. I mean, I guess it's doable, but it's certainly not practical. And so here, modern static analysis tools whose maintainers are staying current with industry trends are going to have support for this standard. And developers can scan their code as they're writing it and integrate it as part of their continuous integration process to make sure that nothing gets missed as they're coding. And so this is my best practices plug on these general points. I'm not going to spend any more time on this because we have a lot of ground to cover when we talk about testing APIs and not just ensuring that the underlying code is well written. So you've built your microservice, you've used good development principles, it compiles, it runs. Now what? Well, before I start breaking the testing process down into the various tactics and methodologies, we need to understand how your microservice fits into the larger ecosystem first. These days, it's commonplace to see hundreds, if not thousands, of microservices grouped into n-tier or multi-layered architectures. And I'm sure we've all seen at least one talk from our friends in Silicon Valley about just how big and complex their distributed architectures are. And this complexity in the deployment is often seen as a reason not to implement microservices. And in fact, this complexity within the monolith that you're decomposing, this is just breaking apart into a complex deployment environment. And so, to the disappointment of the uninitiated, complexity isn't really going away, and it's instead morphing into a new kind of complexity. And so this is probably why we read articles that caution just diving headfirst into microservices, and there are caveats like, the ideal conditions where it makes sense are if you have a large engineering department, right, and you're trying to scale software development across many teams. Um, and so the thing is, the ways that you approach testing APIs or microservices and how you overcome the roadblocks along the way, they're not going to be that different whether your environment is highly distributed, somewhat distributed, or mostly monolithic. The greater the number of integrations that exist, the more acute some of the challenges will be. But the fundamental approaches on how you test these architectures are going to be the same. So I'm going to start with some basics to set a common frame of reference for the rest of our discussion. Like when we think about an API or a microservice as a black box, we can boil it down into the clients of the service as well as the dependencies of the service. And testing your API as a black box means that your test harness here is acting as a client to the service whose job is to verify that it's receiving the correct responses back. And then the dependencies to your service are what the service needs to integrate with in order to function properly and deliver those responses that you're checking. And this talk is going to encompass strategies and optimizations on both sides of the service here, meaning I'll be talking about clients and dependencies. But right now, I'm going to begin at the design phase where the microservice is planned and where the testing strategy needs to begin. And so a well-accepted API development best practice is to implement a service definition during the design phase. And for REST services, I see OpenAPI used most often. And this is what the clients of your service are using to understand what resources and operations your service supports and how your service expects to receive and send data. And within this service definition will be JSON schemas that describe the structure of the message bodies, right? So the client application knows how to work with your API. But service definitions aren't just important for helping other teams understand how your API works. They also have positive impacts on your testing strategy. You can think of them kind of like a contract, right? And contract testing is a methodology that teams use to help them with their API governance. You see, one of the biggest challenges in API testing, just like any software testing, is dealing with change. And with the popularity of agile practices, change has never been more rapid. And so enforcing these contracts is the first step in bringing order to chaos when you're trying to wrangle many teams that are building APIs and then expecting all these APIs to somehow play nice with each other. So how does one go about enforcing a contract? And this should be one of the first concerns in your API testing practice. As part of any regression suite, you should have checks for whether the service definition your team has written has any mistakes in it. Swagger and OpenAPI, they have schemas of their own that describe how the service definition must be written. And you can use them to automate these checks very early in the API development lifecycle. And then besides just verifying the contract itself, you also want to check that the responses your service is sending conform to the contract, right? And so your API testing framework should have support built in to catch these instances where your API is returning a response that might deviate from the service definition. You can think of it like this, right? A car is made up of thousands of individual parts that they all need to fit together perfectly. And if one team who's responsible for the power unit, they deliver an engine that deviates from the design spec, right? You're probably going to run into big problems when you try to hook up that engine to a transmission that another team built, right? And they were referencing the engine's design to know where the bolts need to line up, right? And so this is really what you're checking for here. And these are the kinds of integration problems that good API governance can help you to avoid. And the last point I want to make here about service definitions and how they can improve the testing process is optimized change management. An API testing framework has to help teams bulk refactor their test cases as the API's design is changing so that they can keep up with this fast pace coming from development and really achieve that in sprint testing that everyone's aiming for. And so this can take time, right? Refactoring these test cases, right? Requests may change, responses may change. And so using AI and using the right tool can really help you implement the right process when it comes to keeping your tests up to date. So now I'm going to expand the testing scope a bit and talk about component testing, which is a testing methodology that requires testing your microservice in isolation. And herein lie the challenges, which are knowing what kind of tests to run and also knowing what to do about your microservices dependencies. One of the most difficult things to anticipate as a microservice team that's working on component testing is really understanding exactly how your API is going to be used by other systems. And this isn't really a challenge that's unique to APIs or even software. I mean, consider this, right? Play-Doh was originally used as a wallpaper cleaner. Viagra was originally designed to lower blood pressure. Other teams are likely to discover creative uses of your microservice that you didn't consider. And this is both a business blessing and an engineering curse. And this is exactly why it's important to spend energy to understand what the use cases for your API are. And our discussion about API governance in the design phase, that's an important first step. But even with well-defined contracts and automated schema validation of your microservices responses, you'll never be able to fully predict how the needs of the end-to-end product are going to evolve and how that's going to impact your part of the world with the microservices within your domain. So recording, monitoring, and control are going to help you implement testing approaches that efficiently discover what tests to create while simultaneously helping you automate those component tests when the downstream APIs that are involved need to be isolated from them. And so the enabling technology to do this is service virtualization. Service virtualization brings all three of these concepts to life through one fundamental feature, which is message proxies. And using these proxies in your lower environments lets you monitor and record the message flows between APIs, as well as control the destinations of where messages get sent. And this is going to be the basis for the optimizations I'll be covering today. So how does a message proxy work? Well, they're designed to listen on a given endpoint and or queue, right? And then forward those messages that they receive to the destination endpoint or queue. Basically, they're a man in the middle for your APIs, and you actively choose to inject them in between your integrated systems. And once they're in place, you're really ready to start taking advantage of them. And so before I move on, I wanted to briefly address the differences between orchestrated and choreographed or reactive services. These are just fancy terms that describe synchronous or asynchronous messaging patterns. And so, if your service is communicating using a message broker with protocols like AMQP, Kafka, or JMS, then you're testing a choreographed or a reactive service. And if you're testing REST or GraphQL, that's an orchestrated or synchronous service. And for the purposes of today's discussion, it won't really matter what protocol or message exchange pattern you're contending with, but you might find it more difficult to apply the principles I'll be covering with asynchronous messaging if your framework doesn't have the fully featured support for the protocols that your organization has chosen to adopt. And so we've got two distinct angles here for component testing, right? The clients and the dependencies. So I'm going to talk about the clients first. As I mentioned, it's difficult for a microservice team to predict how other teams are going to be using their API. And we know that end-to-end and fully integrated testing, it's expensive and it's slow. And so using the message proxying capabilities found in service virtualization tools, this lets you record traffic coming from the upstream client applications so that you can capture realistic usage scenarios that significantly improve your knowledge of what tests you should be running within your microservices CI/CD pipeline, where you're not requiring those client applications to always be the trigger, right, that's supplying the traffic to test your service. So in other words, the recording is what enables you to replay these integration scenarios for automated regression testing, where it's going to be a lot simpler and easier to manage than asking those teams to run their tests, which invariably end up testing your API. And this is really why we see tools that combine service virtualization with API testing being so popular. It's because they make it easy for you to record this API traffic and then leverage it for the API scenario testing that's now brought under your control. Next, what about those dependencies to your microservice, right? From this vantage point, your service is the client, right? And then testing your service can be problematic because now you have to rely on another API's availability or test data, or even sometimes capacity to correctly test your service. And this can push the testing effort out of the sprint and makes it difficult for teams to detect these integration issues early enough where they have enough time to react to them. And so what we're discussing here is really the traditional use case for service virtualization, where the technology allows you to simulate or mock these responses from downstream APIs so that you can fully test your API earlier and easier and bring that automated testing into your CI/CD pipeline. And so when message proxies are deployed in an environment, teams can record that API traffic and then build virtual versions of the service that faithfully and realistically reply to your microservice without having those real dependencies in the picture anymore. And this should include stateful transactions, right? Where the simulated dependency needs to properly handle puts and posts and deletes, not just gets. And I say should here because not all service virtualization solutions are created equal. And so this can be a shortcoming with some of the open source options you might encounter out there. And so to summarize where we've come so far in the testing strategy, you've got contract testing and component testing that are born out of the design phase, where you now have the ability to record this traffic effectively, and where it opens the door for getting the right tests automated, as well as isolating your testing from these dependencies using service virtualization. And so now I want to zoom out the testing scope a bit further and talk about integration testing. Here, you want to switch to real integrated environments to ensure that you haven't missed any defects when you're testing against a production-like environment, sometimes referred to as system integration test or SIT stage. And here, you should expect your message proxies to also give you control, over whether you want to be component testing, right, where you're isolating from the rest of the world, or whether you want to be integration testing with real systems in the picture. And another aspect of this control is making sure that the message proxies can easily be managed via API. Organizations that have a high maturity in their CI/CD processes will likely be running deploy and destroy workflows where the programmatic control of the message proxy ends up being a must-have requirement for their service virtualization tooling. And so what optimizations can we extract here from the visibility or observability that message proxies expose when we're in this integration testing phase? And this is where monitoring capabilities can be really handy, right? If you're in the research stages for looking at service virtualization solutions, this should be another requirement to look out for. Do the message proxies expose the traffic that's passing through them in a manner that's easily integrated with your API testing framework? A good solution will expose a monitoring topic that your testing framework can subscribe to, where these messages passing through the proxies can be accessed from the automated test. And this conceptually applies to both those synchronous orchestration layers like GraphQL endpoints that are calling all of these microservices behind the scenes, as well as choreographed microservices, right? These publish and subscribe to events that happen in specific sequences where it ultimately culminates to the function that you're testing. In both of these cases, the traditional testing strategies view these architectural designs as black boxes, right? You trigger some workflow and then inspect the end result. And what monitoring from the message proxies exposes, it's the inner workings of these complex workflows so that you can now implement a better test that tells you where the problem is, not just that a problem exists. So imagine you have some order processing system, right? And it needs to check multiple downstream services like inventory, billing, shipping, right, in order to fulfill an order. And so for a given test input, you should be able to assert against these certain behind the scenes behaviors so that your developers can pinpoint why the test failed. And when your team spends less time figuring out why a problem occurred, they're going to have more time to actually fix it. And so, I wish I had more time here because we're really just scratching the surface. But I wanted to leave you with a couple more honorable mentions related to the strategies I've been introducing today. One, modern mobile and web UIs, they're built on top of APIs. And herein lies another opportunity to capture API traffic from UI testing to help drive your API scenario testing, right? To inform what those scenario tests should be. And these front end APIs may not be as well documented or well tested compared to the core services in your architecture, but that's even more reason to test them, right? And translating an end to end UI test into its corresponding API test, this can really be a daunting task if you try to do it manually. But AI is here to really significantly reduce the time investment when you choose the right tools, right? When you have tools with AI to help you. And secondly, we know that APIs have become the bedrock of how organizations deliver functionality to their users quickly. But functionality isn't the only concern that keeps your management up at night, right? Resilience, performance, security, all of these non-functional requirements, they continue to capture the public's attention with scary headlines. And so many organizations have these shift left initiatives to try and reorganize their software delivery process to account for these important issues. And so using a framework that's well suited to cover both your functional testing and non-functional testing without needing to conglomerate half a dozen tools together is going to cut down on your testing overhead. And so that's another thing that I would recommend here. And so we've got a couple white papers that you might find helpful when evaluating API testing or service virtualization tools. If you want to request a personalized consultation on anything that I've discussed today, you can submit a request to our website, parasoft.com. And here you can find other resources like webinars, case studies, and blogs. I'd also like to invite you to attend our upcoming Automated Software Testing and Quality Summit on November 4th. This half-day event is going to feature companies from multiple industries that are sharing their continuous quality journeys. And you can find more information and register at the link shown or scan the QR code. And so thank you very much for your time and attention, and I hope you enjoy the rest of the conference. All right, Elle, I'll pass it back to you.